Bismillahirrahmanirrahim. In this video we are going to learn about the third method of solving the quadratic equation, and the third method is by that of using the quadratic formula. If you have the, let us take the general form of the quadratic equation. Now, what is the general form of quadratic equation? The general form is ax square plus bx plus c is equal to 0. This is the most general form of the quadratic expression. Now, why do we call it the standard form or the general form? Because this is the single equation which represents all the quadratic equation. Now, if I take different examples of quadratic equations, suppose let us say 7x square minus 8x plus 1 is equal to 0. Okay, and let me take another. Okay, under root 3 x square minus 8x plus 2 is equal to 0, and so on. Now, if you look at all the quadratics, the only difference between these quadratics is that of the coefficients. Okay, over here the coefficients are a is equal to 7, b is equal to negative 8, and c is equal to 1. Okay, in this equation the coefficients are a is equal to 3, b is equal to 1, and c is equal to negative 7. In the third equation, a is equal to under root 3, b is equal to 8, negative 8, and c is equal to 2. So it means that if you look at all these quadratics, the only difference is that of the coefficients. So it means if I change a, b, c, okay, if I put different real numbers in place of a, b, c, I am going to get or generate all the quadratic equations. So it means that this is the most general form which represents all these quadratics and many other quadratics that we have not written. But the only difference is that of the coefficient. If you change the coefficient, you get one quadratic. If you take some other values of a, b, c, you get one more quadratic. And similarly, taking all these, because a, b, c can be any real numbers. Okay, they are any real numbers. If you change a, b, c, you get different quadratic equations. So it means this is the most general form of the quadratic equation. This represents all these quadratics. Okay, if it represents all these quadratics, then any formula that we derive for this quadratic equation will definitely apply to all these, because the only difference will be that of the coefficients. Okay, now the formula that we are going to derive today is, which is also the third method to solve this quadratic equation, is that of the quadratic, that is called the quadratic formula. Okay, the formula that we are going to derive today is the quadratic formula, and it is the formula which can solve any quadratic, because I am going to derive it for the most general form of the quadratic equation, the single equation that generates the whole family of the quadratics. So anything that I find from this equation will be applied to all those quadratic equations which we can generate with the help of this equation. So I am going to derive the quadratic formula for this equation and then apply that quadratic formula to all the quadratics in the exercise 1.2. Okay, the expression of the quadratic formula is x is equal to minus b plus minus b square minus 4ac over 2a. This is the quadratic formula that we are going to find out today. Okay, now as you may see, this gives us the value of x. Okay, and this will give us that values of x which will make this equation true, or which will be the solution of this equation. Okay, x is a variable, it can take many values. The values which make this expression true are called the solution of that equation, and that is what we are going to find with the help of this quadratic formula. As you may see in this formula, the numbers that are involved on the right hand side are the coefficients of this quadratic equation. So if we know the coefficient of the quadratic equation, this is the coefficient of x square, this is the coefficient of b, and this is coefficient of c. Okay, all these constants which are on the right hand side are the coefficients of this equation. It means that we can get all these numbers from this equation. If we are given the equation, we can easily take those a, b, c, put it in the formula, and then get the value of x, which is our actual aim. So first of all we need to learn how we get to this formula. We get to this formula by using the previous method, that is the method of completing square. Okay, I am going to apply the method of completing square on this equation and get this formula, and the method will be the same as we did before. I will take this quadratic, okay, which is the most general equation or the mother equation of all the quadratic equations. Okay, so what am I going to do is I am going to solve it by completing square. Okay, we will solve by completing square method that we did in the previous lecture. Okay, so let us start it. Let us take this equation: ax square plus bx plus c is equal to 0. So the first step that I told you while solving any quadratic equation by completing square is that the first step that we should see is that the coefficient of x square should be equal to 1. Now if it is equal to 1, then it's okay. If it's not equal to 1, we will have to divide it on both sides of the equation. Now over here, a can be any real number. Okay, it may or may not be equal to 1. We don't know it. Okay, we have to do the work for all the values of a. So what am I going to do is I'm going to divide it, divide this equation, both sides of the equation, by a, or I'm going to multiply 1 over a on both sides of the equation. Okay, so multiplying by 1 over a or dividing by a means the same thing. Okay, multiplying 1 over a into ax square will give me x square. Multiplying 1 over a to b will give me b over a x. Multiplying 1 over a to c will give us c over a is equal to 0 into 1 over a is 0. Okay, now the next step that we did was to shift the constant to the right hand side. Okay, the first step is to divide by a both sides of the equation. The second step is to shift this constant to the right hand side. Okay, we will shift the constant term. Constant term means the term which does not involve any x, because over here the exponent of x is always equal to 0 and x raised to the power 0 is equal to 1. So I am going to shift this to the right hand side. Now after doing that, what we did in the previous lecture was that we divided this coefficient by 2, and then we squared it and added it to both sides of the equation. Okay, this is the method of completing square which we have already done in the previous lecture. Now what am I going to do is side calculation. I am going to take the coefficient of x, which is b over a, and I am going to divide it by 2, and it will give me b over a into 1 over 2, which is equal to b over 2a. Okay, and in the next time what am I going to do is I am going to square this number which I obtained by dividing the coefficient of x by 2. So squaring b over 2a gives us b over 2a whole square. In the next step, what am I going to do is I am going to add this on both sides of this equation. Okay, so these are the side calculation that I required to get to this number, which I have to add to this equation. Now coming back to our equation, I am going to write this again. X square plus b over ax plus not plus equals to negative c over a plus b over 2 a whole. Sorry, I had to add both sides of the equation. Okay, so now we have to add b over 2a whole square on both sides of the equation. B over 2a whole square I am going to add over here as well as to the right hand side. Minus c over a plus b over 2a whole square. Okay, I am going to add this on both sides of the equation. Now after doing this, what we are going to get is the complete square of x plus b over 2a whole square. I am going to take x from here, a from here and b from here. A plus b whole square is equal to minus c over a plus this will be b square over 4a square. Okay, this is what I get. Because we have written this, because after adding this we get the square of this number, we get a perfect square. Okay, we get a complete square. In the beginning over here we didn't have the complete square. If you take a is equal to x and b is equal to c over a or under root c over a something, this is not the complete square. But after doing all these steps we get a complete square, because if you open this, this will be a square plus b square plus 2ab will be 2 times x into b over a. 2 will be cancelled and we will get this expression. So it means that if we take a as this and b as this and open this square, we are getting this expression. Therefore I have replaced this whole expression by this complete square, and this is why we call it the method of completing square, because over here we get a complete square after doing these steps. Okay, so now what do we have is that, let me write it here. This expression we got is x plus b over 2a whole square equals to minus c over a plus b square over 4a square. Okay, this is what we got over here. Now we'll continue the derivation. Now okay, now in the next step what we are going to do is we are going to take the square root. Okay, as I had explained to you earlier, we are going to take the square root of both sides. But first let me take the LCM of this expression, okay, so that it looks good. Okay, taking the LCM will be, what's going to be the LCM of these two? The LCM will be 4a square. Now in order to get 4a square, obviously I will have to multiply 4a over here and 1 over here. Okay, so what do we get? After multiplying 4a with the numerator, we are going to get negative 4ac plus b square over the LCM. Okay, so x plus b over 2a whole square is equal to, I am going to write this b square first and this in the second term, because that is what we like to see. Okay, b square minus 4ac over 4a square. So this is the expression we get. Now I'm going to get the square root of both the side. Taking square root of both the side, x plus b over 2a whole square is equal to plus minus c over 4a square. So this will be x plus b over 2a is equal to plus minus b square minus 4ac over under root. I can split this root and apply it to different apply it to the numerator as well as to the denominator. Okay, the denominator is a perfect square, so I can easily remove this square root, because square root of 4 is 2 and square root of a square will be a. Okay, so what we are going to get is plus minus over, we can't cancel this square with this because of this negative sign. Okay, but over here what we are going to get is b square minus 4ac over, this will be 2a after taking the square root. Okay, now I have to find the value of a to get to the solution, the value of x to get to the solution. So x will be, in order to find the value of x, I will have to shift this to the right hand side. So this will be plus minus b square minus 4ac over 2a, or let me write with a different one, giving space so that you don't get confused. Okay, after this step what do we have? X plus, I'm going to shift this to the right hand side. Okay, this will be, I will shift this to the right hand side, and I will write c over 2a minus b over 2a. Now in the next step what am I going to do is I am going to write this first and this second, because it will be more convenient like this. Okay, write that expression first, write this first. Okay, and then am I going to write plus minus b square minus 4ac over 2a. Okay, so plus minus means x will be obtained by either adding these two or subtracting this expression from this. Okay, plus, so x has two possibilities. First one, x is equal to, because we have both these options. Okay, plus and minus, two options. Okay, write it clearly, sorry, plus. Okay, and the other option is minus. Okay, so x is minus b over 2a plus under root b square minus 4ac over 2a, which can also be written as minus b plus, because LCM is same, minus b plus b square minus 4ac over 2a, and the second case was that of the negative sign, x with minus. Okay, x is equal to minus b over 2a minus under root b square minus 4ac over 2a. Again the LCM is the same, so I am going to write it as minus b minus b square minus 4ac over 2a. So these are the two values of x or the two solutions of the equation. Okay, x can be equal to minus b plus under root b square minus 4ac, or x can be equal to minus b minus. Now if, as you may observe, these two are the same as these two. The only difference between those two expressions is that of the plus or minus. Okay, if I write it as in a single combined manner, then I can write x is equal to minus b plus b square minus 4ac over 2a. Or if I write these two together, I'm going to put one minus sign also. Okay, the plus one will be this expression. If you take the negatives with the negative sign, you will get this expression. So this is how we write it in a combined form. Now as you may see, we have obtained the quadratic formula that I had written in the beginning. Okay, this is what we had to derive. If you compare this with the first step that I had written, this is called the quadratic formula. It gives us the value of x by using these two coefficients. So I'm going to write it clearly, and then I'm going to solve one example from the exercise in the next lecture. Okay, now what we got here is x is equal to minus b plus minus under root b square minus 4ac over 2a. Okay, this is what we got. Okay, and this is called the quadratic formula. Okay, by using the coefficients of that I had taken from the general form of the quadratic. What was the general form? Ax square plus bx plus c is equal to 0. What we are going to do is we are going to take these coefficients. In the next lecture, I am going to solve the questions for by using this formula. Okay, this was the derivation only. I am going to take the coefficient. I will pick the coefficient from this equation, and I am going to put it in this formula to get the values of x. And at the most we have at the most we can have two solutions of the quadratic equation, which is obvious from this formula. One will be by taking plus between these two expressions, and the other will be by taking minus between these two expressions. So that's all for the derivation. This was all the derivation or finding the quadratic formula. Okay, so you have to memorize this formula in order to use it, and it is the most direct and simple way to solve a quadratic expression. So up till now we did three methods: by factorization, by completing square, and by using complete square. We have derived a simple formula which is very easy to use. Okay, that we will see in the next lecture, inshallah.